Okay, we are now on question 6, which is from 2014, number 5. This is another straight up hypothesis test. I rearranged your paper, so hopefully you had enough space to write. Obviously, I was squeezing mine in. I did not initially have enough space, but I figured it out, and you can too. So again, let's check. Got the same calculations. Their numbers are a little bit different because they are using the old school formula, whereas we are young and hip and we use the calculator. Let's see what the scoring guideline says. Essentially correct if the response identifies the correct parameter and states correct hypotheses, but not both. What? That's partially correct. Essentially correct is if you state the correct parameter and the correct hypotheses. Let's just double check that I'm consistent with what they said, which I'm sure I am. There's my correct hypotheses. The mu difference, or mu D is what I called it, represent the population mean difference in purchase price, woman minus man. So where mu D is the population mean difference in car price, purchase price, same thing, for a woman minus a man. Make sure you say which way it's being subtracted. So that's essentially correct. Step 2, essentially correct if the response identifies the correct test procedure by name. This is a one sample t-test. Just a t-test would have been sufficient, but really it's a one sample t-test specifically in matched pairs. And checks both conditions correctly. Both conditions should be probably the car models is what they want. Oh, I have both. The random sampling condition can be verified by referring to the random selection of car models or to the random selection of male and female car buyers. But you wouldn't call it two independent SRSs, as they are dependent because they're buying the same car. So two dependent SRSs, which is what makes it a matched pair, or one random sample of car models. And then the other assumption is normality. And this one is normal because our dot plot of the differences is approximately symmetrical. They gave us 3 graphs. We only want to use the one of the differences here. Don't type in the data and get your own graph. Just use the graph that they give you. Make life easier, not harder. Let's see what they said. Sample size isn't large. Oh. The sample size is not large, so we need to investigate whether it is reasonable. The dot plot of sample price differences reveals a fairly symmetric distribution, so we will consider the second condition to be met. Okay. Definitely not a large sample. So that's essentially correct if you have all 3 of those, partially correct if you have 2 of the 3, incorrect if you have less than that. Step 3, essentially correct if you calculate both the test statistic and the p-value. So you didn't actually have to write down the degrees of freedom, but you needed your test statistic and p-value. The alpha comes into play for the conclusion. A correct conclusion in context, also providing justification based on linkage with the p-value. Since the p-value is less than A, what's A? You had to define A, or you needed to say 0.05 here. We reject HO. There is sufficient evidence to say women pay more than men in the same county for the same car model on average. Sure, I have everything. Essentially correct. Yes, yes, yes. Let's look at the notes. If a conclusion is, again, consistent with an incorrect p-value, then step 4 is scored as an E. So if you don't know how to find the p-value, or if you made a mistake and did the 2 sample t-test instead of the matched pairs t-test, then you can still get essentially correct on your conclusion statement, even though you would have gotten incorrect on your calculations. Obviously, never accept HO. Okay, and then again, +1 for each E. 4 out of 4. If you plus 0.5 for each partially correct, 0 for incorrect. Look at it holistically to see if you round up or down.